at the other question, which came in 2018 GCE paper 2. The question reads, a box contains identical patterns of different colors. There are 20 black, 12 red, and 4 white buttons in the box. 2 buttons are placed at random, one after the other, and not replaced in the box. A. Draw a tree diagram to show all the possible outcomes. B. What is the probability that both buttons are white? So in this case, we need to identify these buttons. So they are saying we have got white button denoted by the letter W. We have got black denoted by the letter B, and also we've got the red one denoted by letter R. So how many of these buttons are black? So they are saying 20 are black, then 12 are red, 4 and 4 are white. So how many of the buttons do we have in total? So that will be our sample space. So we're going to say 20 plus 12 plus 4. So 20 plus 12, that will give us 32. Then plus 4, 36. So our sample space will be 36. Yeah. So now let's go to first question. They're saying A. Draw a tree diagram. Tree diagram. So we're going to have a tree diagram that will look like this, which will have 3 departments. So you use Karula, not the way I'm drawing in. So we have one which is white, black, then red. White, black, red. White, black, red. White, black, red. So here on top we have 4 white out of 36. Then black we've got 20 out of 36. Red we've got 12 out of 36. Remember they are saying 2 buttons are selected at random from the box without them being replaced, which means the sample space has been affected. So we are going to get 1 from 36. So that will be now our sample space on the outcomes. So we're going to have 35. So everywhere you indicate 35. 35, 35, just like that. 35s everywhere, so that you shouldn't get confused. Okay, now we go to on top there. So from the white box we can get white from the sample space of the whites. So we're going to have here 3. Okay, can we get black color of buttons from the white ones, we can't. So we are going to get the one for blacks. So the blacks one are 20. So it will be 20 out of 35. Then from the white buttons, can we get the red ones? No, it's impossible. So we are going to get the one for red. How many red buttons do we have? We have got 12. So it will be 12 out of 35. Then we go to the next stage. From the blue buttons, can we get the white ones? The answer is no. So we are going to get the white ones. So the white ones is 4. Then we go to the black. From the black buttons, can we get one black? Yes, we can. So here it will be, what is 20 minus 1? The answer is 19. Then we come to the next one. We've got the red ones. Can we get the red button from the blue buttons? The answer is no. We are going now to get for the red ones. So the red ones are 12. 12 out of 35. Again we come down here. From the red ones, can we get the white ones? The answer is no. Now we are going to get 3 out of 35. Then from the red ones, can we get the blue one, the black ones? The answer is no, we can't get. So we're going to get one for black ones. So the black ones are 20 out of 35. Then from the red ones, can we get the red button? The answer is yes, we can get. So here we are going to have 11 out of 35. Here we are done with the tree diagram. So that is A. Then let's go to B. So here we have got white, blue, white, red, blue, white, blue, red, white, blue, red. Now the question is for B. What is the probability that both buttons are white? So the probability that both buttons are white is coming from here, white. Okay. So we are going to say probability that both buttons are white. So we are going to say W is equated to 4 out of 36, 4 out of 36 multiplied by 3 out of 35. That will be our answer. So here we can make use of 3. 3 can go into 3 one time. 3 can go into 36 12 times. Then let's say 4 multiplied by 1, the answer would be 4 out of, what is 12 multiplied by 35? It will be 420 when we say 12 multiplied by 35. So we have 420. 4 can go into 420. How many times? So 4 into 4, 1. 4 into 4, then 1, then 5. 15 times. So it will be 1 out to 15. Probability that both are white equal to 1 out of 15. So that is all about probabilities. The next time we'll look at the other topic.